All right, find all the real zeros. Same idea, it's just a higher degree. So I'm going to start by looking at P over Q. And again, I have the factors of my leading coefficient are 1, so I'm not going to bother writing my fractions. Okay, factors of 75, real familiar number. 1, 3, 5, 13, and actually, I don't think that should be a 13. That's 15. I had it wrong on the last one. And 25. Well, now that bothers me. Is that the case? Yeah, 5 times 15, yep. Okay, so again, I'm going to start with a positive 5, see what happens. And I'm leaving myself a lot of room because trial and error. Do I have any missing terms? No, on 4th degree I have 5 terms, I'm fine. Okay, so 1, 5 times 1 is 5, 6, 30, which gives me 8, 5 times 8 is 40, that'll give me 15, and again, got pretty lucky, 5 times 15 is 75, which gives me a 0, and that tells me that I can rewrite it as, well, I'm not going to do that. I know that 5 works. Is 5 going to work again? Well, I don't see any negatives in there. Let's try a negative 5. And I'm going to just do that on the remainder. Okay? It's one way to really save time here because I don't have to rewrite it. 1, negative 5, 1, negative 5, 3, negative 15. That also works. All right. So I get my real zeros are x equals 5 and, well, negative 5. Sorry, 5 and negative 5. And I'm left with x squared plus x plus 3 equals 0. Now, I want to know if that's going to give me any real zeros. It's not factorable. I can't think of two numbers that multiply to give me 3 and add or subtract to give me 1. So it's not factorable. And if I do the quadratic formula, let me write this, x equals negative b plus or minus square root of b squared minus 4ac all over 2a, I'm just going to take a look at b squared minus 4ac. If that turns out to be negative, then my answers are non-real and I don't have to calculate them. If it does turn out to be positive, then I'll just plug that number back into my square root. So b is 1 squared minus 4 times 1 times 3. Now, this is going to give me a negative 11. So non-real solutions, my only 2 real solutions are the 5 and 5. Okay, let's take a look at number 8. Okay, this is kind of a strange idea that is really helpful if you don't own a graphing calculator. It basically tells you what to expect out of any given polynomial, how many roots you're going to have, and what kind you're going to have. So we're going to get a 0 on one side here. I'm going to add 2x to the third. And we get 2x to the third minus 4. Okay, so we look at the sign changes. Okay, so the first thing we need to be aware of is that for a third degree, I'm going to have 3 roots. Okay, some of them might be multiples, some of them might be not real, but this helps me figure out what kind of roots I have. So we look at the sign change with just plain x, and we have 1. Okay, that tells us some idea of the positive roots we could have. So we have 1 sign change. So we will either have, well, we'll have 1 positive root because we go down by roots by even numbers. Since 1 is an odd number, we can't go down any farther. I'm trying to record this during lunch, and the announcements are really annoying. Not much I can do about it. Okay, so the second step is to figure out how many negative roots we have. by looking at the same equation, only putting in a negative x everywhere we have an x. So what that does is it changes the sign of my first term, because negative x to the third will make my first term negative. When I look at that, I go from negative to negative. I have my negative roots are going to be 0 because I have just one sign change. It's not you, it's the announcements. Okay, so if I have a total of 1 positive root, 0 negative roots, then that means that